Well, welcome to, are people like, yeah. Hi, everybody. Hello, welcome to our workshop with Angela Liu. We'll be going over zkSync SDK. And I will let Angela take it over and go on with the workshop. Thank you very much.
Hi, everybody. I'm Angela, and today I am joined by Igor and Stas, who are going to be in the chat answering any questions that you might have along the way. And today we are going to do a bit of today we're going to do a bit of a zkSync 101, and basically everything you need to know to be able to build on the zkSync SDK. But I did not come empty-handed. I brought you guys first a little surprise gift. So in 2021, in May, zkSync will be launching swaps on Mainnet, which means the trading of fungible tokens via atomic swap and limit orders. Coming with swaps will also be NFTs coming to Mainnet, and we will support the functions mint, transfer, and atomic swap on layer 2, as well as the withdrawal to Mainnet. And then lastly, we have the zkSync 2.0 coming to testnet in May. zkSync 2.0 is our EVM-compatible ZK rollup. We built a snark-friendly LLVM engine, so this means portable Solidity code and Ethereum wallet native support. And this will be coming to Mainnet in August. We are aiming for virtually no difference between the ZK EVM and the EVM. And if you want to know more about how we built the ZK EVM, tune in to the ZK Summit in this hackathon during week 3. In October, we will also be introducing ZK Porter to Mainnet as part of zkSync 2.0. This is our engine for mass adoption, and we are aiming for 20,000 plus transactions per second, with even more security guarantees than that of optimistic rollups. We just released an article on Twitter today on our Medium, but if you want to know more about given in a presentation form, tune in on Friday, April 16th, which is this Friday. So let's begin. Today, we're going to first take a bird's eye view of our rollup architecture, and then we're going to talk a little bit about how our rollup communicates with Mainnet. And then we're going to go over our initial user flow, talk about some functions that are available for you in the zkSync SDK, and then we're going to talk about a fun topic called transaction batching. But before we get started, I wanted to introduce to you a few tools that you're going to need everything that you're going to need to become an zkSync developer. So the first tool that you're going to need is our SDK docs. Here you can see that there's the JavaScript and TypeScript libraries as well as Rust. Next is going to be our zkSync GitHub. I have highlighted 3 folders that you're going to be frequenting the most and are going to be most important to you: the contracts, docs, and the SDK. These 2 files, the zkSync file and the protocol file, are going to be the most frequently visited for you and the most important as well. So let's begin. Let's talk about the ZK rollup architecture. The ZK rollup architecture is split into 2 parts. The first one being that on Ethereum. And these are our Solidity smart contracts deployed on Mainnet, which are managing your user funds. Next is going to be the rollup side. And this acts sort of like a sidechain that produces rollup blocks and executes rollup transactions. Currently, this sidechain is secured by the zkSync server, but will soon transition to proof of stake via the zkSync token. Next, let's talk about how Mainnet and the rollup communicate. So we have zkSync servers always including transactions into rollup blocks. And once included, these funds from your transaction will be usable in 1 to 2 seconds. Once there are enough transactions to fill a block, we call the function commit blocks. And this is when the smart contract receives a commitment that transactions have been executed in layer 2. So the server is receiving these committed blocks, and the server starts generating these proofs right upon receiving the block in parallel. So this means that there are 10 committed blocks. then the server is generating proofs for 10 of those blocks in parallel. And once these zero knowledge proofs are generated, we will call proof blocks. And here, the smart contract receives the proof that all transactions in layer 2 are correct. Next, we'll call the function execute block. In this, the smart contract updates its internal state with the information received in the commitment step. And at this point, transactions are considered finalized. And these three functions can be found in the zkSync file that I showed you earlier. So next, we're going to talk about the initial user flow. So the user first has to start by sending funds to the smart contract by calling deposit to sync from Ethereum. But if you're depositing an ERC20 token, you have to remember to approve the token by calling approve ERC20 token deposits. And you can find these two functions in the SDK folder in the wallet file. So if this is successful, then the smart contract will emit an event called deposit. And the zkSync server is always monitoring Ethereum for events. So when the zkSync server sees this deposit event, it'll create a priority operation. And we'll talk about what that means a little bit later. So now in layer 2, the user balance is increased by the token amount for the specified token. But there's a little caveat to this. If this is your first time using zkSync layer 2, you first have to initialize your account by calling set signing key. And you only have to do this once. This function can be also found in the SDK folder in the wallet file. But as I said, this will be deprecated in zkSync 2.0 as we will support Ethereum wallets natively with ECDSA signatures. So let's talk about functions. So as I said, we would come back to priority operations. And there are two types of priority operations: deposit, like I talked about, and also full exit. And full exit withdraws the full balance of one token from the zk wallet. This function is used in case L2 transactions are being censored by the server. And although unlikely, this is for the ultimate security. And if this still doesn't work, and the server is either not working, compromised, or is creating blocks that are ignoring priority operations, such as your full exit, the contract will enter exodus mode. And here, the contract will freeze all funds, and all users will be able to withdraw their funds. Next are the basic operations, which are your favorite because they are cheap layer 2 transactions. There are three types of basic operations. The first type is transfer. And here you can send ETH or ERC20s from one layer 2 account to another. Then there are two types of withdrawals. The first type of withdrawal is a normal withdrawal where you can just withdraw your ETH or your ERC20 tokens to mainnet. But the second type of withdrawal is called forced exit. And this is used when you cannot set the signing key. For example, if your address is that of a smart contract. And here, to withdraw, you would call forced exit rather than withdraw. Lastly, we're going to talk about batching. Batching transactions means that these transactions will either succeed together or fail together. And this can be analogous to flash loans. And some creative use cases include paying the transaction fee in your ERC20 token, but we're going to focus on the Gitcoin grants case study. So the user starts by picking their grants, and then after the user finalizes the grants that they want to donate to, they move to zk checkout. Then behind the scenes, all the magic happens. Gitcoin grants batches all these donation transactions, sets the signing key, and pays the fee for all the transactions at the end. Wow, so smooth. And that's it.
Do you have a link you can provide on the summit you were talking about?
That has not been set yet, but it will be set as week 3 in the hackathon.
Okay, thank you.
Hi, I was wondering, so Stanislav, thank you for answering so many questions, but I'm a bit confused now. So can we deploy smart contracts onto zkSync using your Zinc language, or do we, or is that not possible until zkSync 2.0?
Yeah, so zkSync 2.0 will come with full smart contract support for Zinc and Solidity. So we can't do that just yet.
And no, and I saw on the documentation for Zinc that there's something already for the Rinkerby mainnet, the Rinkerby testnet, right?
Yeah, I will clarify that. So basically, Sync is two related but very different purpose or projects. So the first version of Sync was Turing incomplete, and it had a lot of limitations, and we actually had a separate testnet in which you could try to write contracts in Sync and deploy it to that testnet. But it never got to production because we found a way to make Sync fully Turing complete, and moreover to transpile existing Solidity code. So we decided to not continue the previous Turing incomplete version and focus on the Turing complete version instead, which will be available in May.
Thank you for your answer. And will we get early access to the smart contract functionality? So before the hackathon ends?
No, I don't think so. Once testnet is ready, it will be open for everyone, but we are targeting May.
So we have some questions from YouTube. One of them asked if exchanges are planning to make direct withdrawals to ZK rollups. And yes, we are partnering with many exchanges so that users don't even have to go through L1. They can just directly transact from L2. And Igor, did you want to answer about gas efficiency from Solidity or the first question?
Let me see. I'm not sure if I understand the question.
I hope I understand. So if the question is about if there will be any difference between Solidity or Zinc on layer 2, then the short answer is either no or it will be very small, because the main price from contract executions comes from public data that is published on ZK rollup. So it will be just the same for both Solidity and Zinc contract, if we understand the question correctly.
And regarding the Starks in the future, I believe it is not in the near-term future, but maybe maybe like in the long-term future, we will transition. But the cool thing about how we're able to support the ZK EVM is the fact that we figured out recursion in the Planck system that we use. And then another question is, currently, is it just doing payments? And yes. So the creative avenue here is the last slide that I mentioned, batching transactions. And you can do up to 50, which is the amount that can fit into a bill.
Hey, can I ask a question?
Sure.
So how does multi-signature wallets work with zkSync? Like, would it be the exact same way as in Ethereum?
I think Stas can answer.
I think there are two parts and answers of your question. Well, first part is that zkSync actually supports natively multisigs, but they're like n of n, so you need all the signatures for the multisig to send any transaction, and it's already supported. They just send transfers. And if the question is about more complex multisigs, then I guess they'll be available on, they will be available when the zkSync 2.0 launches, and they'll be just the same as the ones on layer 1, because the smart contracts will be supported, just the very same smart contracts. So
Cool, thanks. Yeah, I asked because I couldn't really find any reference on how to work with multi-sig wallets, but I guess it's somewhere there I didn't find.
Cool. So there's a question asking, is there going to be more native languages for writing smart contracts on zkSync? One that might be more efficient than EVM porting? And yes, so Zinc currently is non-Turing complete, but in zkSync 2.0, it will be Turing complete. And it is designed after Rust, and it's designed to be a lot more safe and a better user experience than Solidity. And it's also specialized for generalized zero knowledge proof circuits. Another question from YouTube. Will zkSync 2.0 support L2 contracts calling functions on L1 and vice versa? For instance, on Optimus and L1 can call L2 functions immediately, but L2 has the delay time to call L1. Does Igor want to take that one?
Yes, there will be layer 1, layer 2 interoperability, but not in the first version that comes in May. The first version will come without layer 1, layer 2 interoperability, and it will be added later.
The next question is asking where the zkSync servers are and if they're secure. I'm not sure where exactly they are.
Yeah, so right now, the zkSync server is managed by Matter Labs. It's being hosted in a cluster. It's pretty secure. And actually, the architecture of the zkSync is kind of indifferent on where server is located and whether it's secured, because even if the server becomes compromised, there are knowledge proof just will not be generated, or it will be incorrect and will be declined by the zkSync smart contract on layer 1. In the future, however, there will be a fully distributed model with multiple validators and proof-of-stake algorithm.
Right, so we're going to be doing progressive decentralization in respect to the zkSync servers. The next question is, given only the payment SDK is available for the hackathon, what kind of tools would the zkSync team like to see? In particular, are there any SDK reference guides you could link us to? So first, you can check out the prizes link that maybe Catherine could send in the chat. And here we listed some cool tools that you could use that we would like to see built. And like I said, the best SDK reference guide is the first link that I said in my presentation. And you should be able to find it by going to zkSync.io and going to the docs section. It should be developer docs, it should be right there. Another question from YouTube, what's the usage of the zkSync token? So we're going to use the zkSync token to secure our network through proof of stake. So the validators in the ZK rollup side, so in the future, zkSync 2.0 will become split into the ZK rollup side and the ZK porter side. And basically the zkSync token will be used for proof of stake. Another question from YouTube, kind of confused what tech we will have access to for the hackathon. Where should I look at? So you should look at the SDK. It has very detailed documentation about the kind of fun, learning about how zkSync works and things that you will be able to build on top of zkSync. And also, I have listed in the prices section some examples of tools that we've built, such as the ZK wallet, a ZK link, which generates payment links. We would really like to see a tool for mass payments or multi-sigs. That would be really cool. Or we could do, we're looking for cool integrations, such as what Gitcoin Grants did. Another question, are zkSync's bridges similar to Optimism's and Arbitrum's in that in the beginning, there will be a centralized bridge, but there's a plan to decentralize going forward? Or does zkSync even need this trusted bridge software? Igor, do you want to take this one?
I'm sorry, can you repeat, please?
Yeah, so they're talking about how zkSync, if zkSync will have bridges similar to how Optimism and Arbitrum has centralized bridges. Or do we even need this bridge to that one?
I'm not sure if I'm ready right now to provide technical details on that.
Okay, cool. So we will take a rain check on that question. The next question.
I want just to say that we will. Okay, so but there are some bridges which only require AVM support. So if some bridge wants to be created between zkSync and any other system with AVM compatibility, I think it will be possible since zk EVM is AVM compatible.
Cool. So the next question is from YouTube. It says, I think you answered this question, but I missed it. Will there be an official ERC 721 contract for zkSync coming soon? Yes. So NFTs will be on Mainnet early May, and we will be supporting mint, transfer, and atomic swap on layer 1 and also withdrawals to layer 1. I might have misspoke. Mint, transfer, atomic swap on layer 2. Is there any concern that open public smart contract publishing on zkSync 2.0 result in unmanageable proof generation time? Is this a linear or exponential relationship? Amount of smart contract logic versus proof generation? Great question. So, if you look back at the slides, I talked about there's 3 steps. There's commit blocks, and then there's proof blocks. So once blocks are committed by the zkSync server, proof generation starts right away. And each time a new commitment of a block is received, it's going to start right away. So these will be in parallel. So if there's 20 or 30 commitments altogether, the proof generation will be in parallel, and then they will start. So yes, it will be. Another question from YouTube. Will our experience playing around with zkSync on this stage be useful when EVM compatible zkSync 2.0 comes out? Good question. So I tried to keep this presentation with as little deprecated things that we're going to remove from zkSync 2.0. And so everything except the set signing key in this presentation will apply.
Great. So I don't see anything else coming up on YouTube. If you guys have any more questions, please, we have a couple more minutes left, so feel free to ask anything, take the mic.
Yes, and while questions are trickling in, I will just take a moment to promote our ZK Porter, which is our exponential scaling engine. And we just released a Medium article detailing it today. You can find it on our Twitter or our Medium. And also, we will be having the ZK Porter talk on Friday, and then the ZK EVM talk about how we created generalized smart contract circuits. I'm sorry, general zero knowledge proof circuits. called the ZK EVM on week 3 of this hackathon during the ZK Summit. And I can also post the Discord link, but if you have any questions. Oh, there's a question. Where are events emitted by smart contracts posted, mainnet or somewhere else? Right, so smart contract events, you should be able to see just like normal because they're on mainnet. Let me find our Discord link. Cool. I will put it in the chat. And if you have any questions, feel free to join and ask here. And also there is a channel in the ETH Global Discord. Will V2 have a limitation on the size of the bytecode of deployed contracts? Optimism has this limitation. Igor, do you want to take this one?
I'm not sure right now. There is no real limitation on the code size itself, other than like the storage capabilities of the node, but maybe there will be some technical limit just to not allow unlimited code size and prevent the case of abuse. But I don't think that it will be some kind of limit that will affect a lot of users.
Awesome. Any more questions before we wrap this up? We still have a minute or two left. Otherwise, I'll direct you to the Discord. Now or never. All right. Seems like. Oh, we actually have one more here. Do you consider using enclaves TEES to ensure the correct L2 execution of contracts?
I didn't quite catch what you said the first
Oh, sorry, I'm just reposting it.
I do not know what that is. Igor, do you know?
I'm not sure as well. I'm sorry.
It's all good. All right. Well,
but the L2 execution of contracts will all be verified through zero knowledge proofs. So.
Great. So I'll just invite everybody who has still a question, or if you want to expand on any of these topics, please go to the Discord channel. There's a specific sponsor channel specific for zkSync, and the whole team is there to answer your question and support you through the hack. And I know they'll be more than happy to support you. So a very huge thanks for everything, Angela and Igor and Stani. It was a really great workshop, and I really appreciate having you.
Great. See you guys on Friday for the ZK Porter Shop.
Yes. Awesome.